So hello everyone, welcome to Programming Knowledge. So welcome to yet another tutorial at Programming Knowledge. So today's tutorial is bit magic and tricks to cover the binary representation of a number. So today we are going to learn about very good tricks. So how we can work with bit magic. So basically, this is going to be a very interesting tutorial. So we are going to see bitwise operators, then how we can use them. So today we are going to cover very good topics. So let's get started with this. So basically initially we have six bitwise operators. So let's cover them one by one. So the first bitwise operator. So the first bitwise operator we have is this AND operator. So this is bitwise AND operator, and this is bitwise AND operator. The next is bitwise OR operator, and this is this symbol. So the at rightmost the symbol at the rightmost statement is the operator we are talking about. So next is bitwise NOT operator. This is bitwise NOT, and the next is bitwise XOR operator. So this is bitwise XOR. Next is bitwise right shift. Okay. Right right shift, and this is this. And the next we have is bitwise left shift. Okay. So let us start with a very basic application. Uh, so let us start with a very basic application. So let's start. Let's take some numbers here, and I'll use AND operator. So first I'll show you a application of bitwise AND operator. So this is the first application we are talking about, bitwise AND operator. So let me perform an operation 2 and 1. So you can 2 and 1. This is 0. I'll do 4 and 1. Again 0. 6 and 1, again 0. 324 and 1, again 0. 500 and 1, again 0. Let me take another number, 3 and 1, 1, 9 and 1, 1, 23 and 1, 1, 325 and 1, 1, 501 and 1, 1. So you must have got the pattern that these were all the even numbers. 2, 4, 6, 324, 500 were all the even numbers, and below it were all the odd numbers. So you must have got the pattern till now, that above were all the. So I'll just quickly give you a recap. Even. The bitwise resultant with and 1 was 0000. This was odd, 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 odd. So bitwise result of with and 1 was 11111. So this was the result. So we can define even, odd, and. So if and 1 is equal to 1, then print. So we are going to print odd. We are going to print odd. Else what we are going to print? Else print even. Okay, and we are going to take test cases here. T is equal to int input, then while t is equal to t minus 1, then n is equal to int input, then we take an integer input, then print even. Sorry, so we already have a print statement in the function. We'll directly call it even odd of n. Okay, so we'll take some 5 test cases here. 1 odd, 2 even, 3 odd, 325 odd, 500 even. So we had 5 test cases: odd, then again even, odd, odd, even. So this was a very basic statement. So this is pretty much quicker in terms of if you have a very large number and if you want to check if it's an even and odd, then you can use this bit magic operation. Okay, so next trick we are going to see here is, so basically next trick we are going to see here is left shift and right shift operators. So let me take an integer n is equal to 32. Now I would type n right shift 2. This is 8. So please keep a note of this result. N right shift 2 is 8. Okay, let me do n left shift 2 is 128. Okay, never mind. We have a one. We will have a new number. M is equal to 200. So please keep a note of it. So what was I'm so we'll have m right shift m right shift 3. This is 25. Okay, so I'll tell you the trick. Basically, right shift is divide in the power of 2. Uh, I'll type it. I'll type it here. So basically, right shift right shift is divide in power of 2, and left shift is multiply in power of 2. So this is interesting. We'll check this. How is this possible? So what we are going to do? So we'll see m is equal to 200. M right shift 3 is, so basically what I mean, m is equal to 200, and we are going to divide this by right shift 3, that is 2 to the power 3, which is equal to 200 divided by 8, which is equal to 25. So this is our calculation. Now if we take m is equal to 400, okay, m is equal to 400, and I'll do m left shift 4, which is equivalent to 400, because this is a left shift. We are focusing with the multiply, that is multiply in the power of 2, that is multiply the 2 to the power 4. So this is equal to 400 into 16, so that would be 4800. Oh, I okay. I was really sorry with the calculation. So I was mistaken here. That is 4 into 16. Okay, so I'll correct this statement. Yes, yes, this is 6400. So basically, because 4 16s are 4 into 16 is 64, and that is 100, 6400, because I had a 3 in the mind. So something. So really sorry for this. So this is 6400. So basically, so I'll take one more example. I'll take uh, a is equal to 100. So this okay, a is equal to 100. Now I'll do a right shift a right shift 2. So I that is divide a divided by 2 to the power 2, that is 100 divided by 4, that is 25. It's perfectly fine. Now I'll do a left shift 5, that is a into 2 to the power 5. So basically, which is equivalent to a into 32, which is equal to 100 into 32, which is equal to 3200. So I hope I'm correct this time. So please make note of this mistake. Okay, so this is 3200. So this was, so basically left shift and right shift operators are used to for the if you want to divide in power of 2, you can use the right shift, and if you want to multiply in power of 2, you can choose left shift. So we can do def multiply. We'll define def multiply n and return n star uh, def multiply. If you want to multiply a power, so you can let me n right shift. Yes. So yeah, and we in the same way we are going to define divide x, y, return x. So we can comment this statement here, and for we are going to take two integers. So you today I'll tell you how you can do x comma y is equal to map. The map function allows you to take input in a separated manner. Int input dot split, and then I'll define this function as multiply in power of 2. So multiply power 2 and divide power 2. So this would, and then I'll call this function multiply power 2 x comma y, and divide power 2 x comma y. So let me take one test case here, then I'll take 100, then 2. So okay, I had returned this, so I need to use print here. Print, 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 and here it is again a print. So 100 and 2. So when I did multiply, so this was multiply by 2. That is 2 into 2 4. That 100 into 4 is equal to 400, and if I divide in the power of 2, that 100 divided by 2 to the power 2, that is 100 by 4 is equal to 25. So this was until now we covered how we can use bit magic. So we are going to thank you guys, thank you so much. I'll catch you in the next tutorial.